Hi, this is part 2 to the notes 4.5, topic 4.5 AP chemistry. We have been talking about limiting reactants and solution stoichiometry, precipitations. So let's switch now over to gases. So molar volume, 1 mole of any gas at STP, which is 0 Celsius and 1 atm. The volume of that mole is going to be 22.42. For our calculations, we're just going to use the 1 mole is 22.4 liters. So you can only use this if it's a gas at those conditions. If not, you can still do stoichiometry up to the mole amount, and then if it's a gas, you would then use the ideal gas law too, if the conditions were different. So let's do an example. I'm trying to find my notes on this. Oh yeah, here we go. So we are going to do an example. So I highly recommend that you try it before you do it. When you're doing a question like this, and this is a typical AP type question, they're asking you a lot of different questions below. So it's really, even though it's not an FRQ, you do need to figure out which one is the limiting and the excess, how much excess there is. And then once you know the limiting, then you can easily calculate. You can see C and D are both products. You could just by chance pick the correct one if you only do one of the calculations, but you for sure would have to calculate which one is the limiting reactant. So in this question, I'm going to just show my work down here. So the first thing I'm going to do is they gave me 30 mils of hydrochloric acid. And actually, I think there's a typo. I think this is supposed to be 1 molar. So we'll change that to a 1. Oh, yeah, it is. But 30 mils. So I am going to convert that into liter. Then I'm going to use the molarity. So this is solution stoichiometry right here to calculate my moles of hydrochloric acid. So I get 0.300 moles of HCl. And then they tell me that I have 0.56 grams of iron. So I'm going to convert that also into moles using its molar mass. And when I do that, I get 0.0100 moles of iron. So the next thing is I would determine the limiting. So I'm going to show you both, but you can just choose one of these. So if I react all 0.0300 moles of HCl, now I'm going to use my mole. I would need 0.150 moles of iron. And you can see that I don't have that. So that means this is my limiting, this one's my excess, and I'm not going to use that number. Or let's say you chose the other way. So you took your moles of iron and you calculated how much hydrochloric it would take to react with all of that iron. And you can see that we have plenty. In fact, we have 0.0100 moles of excess of that hydrochloric acid. So my limiting is the iron, my excess is the hydrochloric. So the first question, or I think the first option was HCl is in excess. It is. So A and B might be true. So what we would want to do then is calculate how much left over there is. And what I would do there is, remember, I take my excess reactant amount that's given, subtract the excess reactant amount that will actually react, and then that's how much leftovers, unreacted. So in the question, I have 0.0300 moles of HCl, and then right here If you hadn't done that, you would want to calculate that amount. And then, so if you had just done the first calculation here, then you knew the iron was your limiting, then you would have had to take the iron, calculate how much of the hydrochloric really reacts. And then when I subtract, there's 0.01 moles of HCl left over. So if I go up here, this way, something's wrong. 0100. Oh, yeah, this is two. I was thinking it was the same number, but neither one of these is 0.0100. So we now know it's not A and B. We do know our limiting reactant, so let's calculate, let's do C and figure out how much of the iron 2 chloride we're going to have. We're going to only go to moles, so I'm going to take my moles of my limiting and calculate the moles of the iron 2 chloride that will be produced. And yes, it's a 1-to-1, but I would still expect that you showed your work or you explained that. So we're going to produce 0.0100 moles of iron 2 chloride. And you can see this is not the right answer. So that leads us to D, but let's confirm it. So D should be our correct answer. So let's take our limiting reactant again. And they want to know how many liters of hydrogen. And it is at STP, so I can use 22.4. So I'm going to first convert over to moles of hydrogen using my coefficients in the balanced equation. Then I'm going to use the molar volume of any gas, including hydrogen, at STP. So when I calculate this, I get 0.224 liters of hydrogen. And you can see in the question that is going to be letter D. All right, let's do another one. So that was the same one. Sorry. Here's another example. This is example 18. In the question, we have 6 moles of C3H8 and 20 moles of chlorine. And after one of the reactants has been totally consumed, how many moles of HCl? So we're going to want to know how much HCl, but before we do that, we have to determine the LR. And when we do the LR, we can take our 6 moles of C3H8, convert it into moles of chlorine, and I get 24 moles of chlorine. And you can see I don't have that. So that means chlorine is my limiting and the C3H8 is my excess, and I am not going to use that number. If you want to confirm this, or if you'd chosen the other way, we would have taken 20 moles of chlorine and then multiplied it by 1 mole of C3H8 over 4 moles of chlorine, and then we would get 5 moles of C3H8, and we can see in the question we have 6, so that means we have plenty, so excess reactant. In fact, we have, if we were going to determine, we'd have 1 excess mole of C3H8. But in this question, they just want to know the moles of HCl. So now that I know which one's my limiting, I'm going to start with my limiting reactant, and I'm going to calculate how many moles of HCl are produced. So 20 moles of HCl. So that means that my answer is C. All right, let's do another one. So this example, we are looking at a reaction, the production of ammonia, and we have, the models. So what I recommend that you do is count. So you can see that we have 3 of the blue diatomics, nitrogens, so 3 moles of nitrogen for every 2, 3, 4, 5, 6 moles of hydrogen. So the first thing that you would want to do here is we would want to determine the limiting reactant. And sorry, I'm going to add a page here because I'm going to run out of room. So I can, take my moles of nitrogen and use my mole ratio. And I get 9 moles of hydrogen would be needed to react with the 3 moles of nitrogen. So we do not have that. We only have 6 moles, which means this is my limiting and the nitrogen is my excess. I'm not going to use that 9. But let's do it the other way and make sure we agree. If I were to have picked the hydrogen, 6 moles of hydrogen, convert it into nitrogen, I would have gotten 2 moles of nitrogen. And you can see that I do have that. So that means the nitrogen is my excess and the hydrogen is my limiting. So now they're asking me what would be present. The image represents what would be present after the reaction. So I'm going to start with my LR and calculate how much ammonia can I make. So I'm going to use my mole ratio. So 2 moles for every 3 moles of hydrogen. So I'm going to have 4. I'm going to have 4 moles of ammonia, NH3, that I'm going to draw, or I would just talk about. And remember, our excess reactant is also going to be in the container. So we know that we would only react 2 moles of nitrogen, but we were given 3. So excess reactant, we're going to take our 3 moles of N2 that were given minus the 2 moles that are actually going to react. So there would be 1 extra mole of nitrogen. So if I were going to draw this, I would want to draw, I'm just going to grab a different color here, 4 ammonias. And remember the color there was blue. And then each one has 3 hydrogens. Whoops, that one I put too many on. And then we also have 1 mole of N2 left over. So that would look kind of like that. All right, let's do another problem. Similar, in fact, very similar. So example 20, highly recommend that you try this one and pause the video and then see how you do. So in the question, just really very similar to the previous question, we're trying now to pick which picture represents, which one is the the correct diagram. So in the question up here, they're telling you that you have 3 moles of hydrogen and 3 moles of nitrogen. And again, this is one where I think you can figure out who the limiting is without showing your work, but I am going to show mine. So I'm going to take my 3 moles of hydrogen and I'm going to convert that into moles of nitrogen. So I need 1 mole of nitrogen to react. And you can see that, remember I have 3. So that means this nitrogen will be my excess and the hydrogen will be my limiting. So right away, you know that you're going to pick a picture that has nitrogen, which is going to look, like this, left over. But let's just confirm. Let's say it went the other direction, that you took your 3 moles of nitrogen and converted into moles of hydrogen. Then you would have gotten 9 moles of hydrogen would be required to react with all 3 moles of nitrogen, and we don't have that. So we would not even use that number. This is our limiting, and this is our excess. So now that we know who the limiting is, we're going to start with our limiting, the 3 moles of hydrogen, and try to figure out how many moles of ammonia should we draw. And when we do this, you can see, I'm doubting myself now, 3 moles, 3. So you would need to draw 2 moles of ammonia. And then, like I said, already you know the answer is E, but because remember we said our excess reactant was the nitrogen, but we could have taken the 3 moles of the excess reactant nitrogen minus the 1 mole that will react. That would give us 2 extra moles of nitrogen. So we know with a lot of certainty now that the correct answer is E. Let's stop there, and then there'll be another video.